Dear students, welcome to unit number 4, fifth topic, testing of hypothesis, inferential statistics, parametric and non-parametric statistical test. Test of significance and are applied usually for normal distribution, that is called parametric test. So what is this testing of hypothesis? Generally, hypothesis is there for the quantitative research. Hypothesis simply means the relationship between two variables. For example, income and education status. Education status and participation in Gram Sabha. Educational status and employment. So there are different variables which may be associated, and the hypothesis says there is a positive association. Null hypothesis states there is no relationship. So whether there is a relationship or not is to be tested with the help of two types of tests. One is called parametric test, the other one is called non-parametric test. Parametric test is mainly used for quantitative research, where the observations are said to be normally distributed. Tests of skewed or non-normal distribution are known as non-parametric test. Example is sign test and chi-square test. These non-parametric tests are used mainly for qualitative research, or at least one of the variable is qualitative. For example, caste status, educational status, social status, these are all qualitative parameters. On the other side, it can be quantitative variable, means the income, expenditure, etc. So we must know what kind of variable we are dealing with before deciding upon the type of test to be used. If you are purely dealing with quantitative information like age, income, weight, height, etc., then you can very well use the parametric test, which is called the t-test, student's t-test. It is generally used for purely quantitative research, where the variables are said to be distributed normally. Normal distribution means a bell-shaped curve, which means 90% maximum observations lie in the middle, and at the extreme there are very few observations. In other words, we can say 99% of the observations lie between the distance of 2 standard deviation from the mean. Now, there are again two types of test of significance. One is called two-tailed, the other one is called one-tailed. If the direction of the association is known in advance, we can use one-tailed, otherwise we have to choose two-tailed test. What does it mean, one-tailed and two-tailed? Suppose we know higher the income, higher the expectation, which means we know in advance there is a positive correlation between the income and the expectation, which means we have to use the one-tail test to assess the significance of this relationship between income and expectation. Suppose we don't know the direction of the association. For example, educational status and crime rate. We do not exactly know. Sometimes we find there are people who are highly educated, engaged in very severe, serious crimes. We also find that people with poor education or illiterate people are engaged in petty crimes. So, the association is not clearly proved whether positive or negative. We can't clearly state that higher education means low crime, or we cannot also say higher education means higher crime. In this case, when we are not clear the direction of the association, we can safely use the two-tailed test. Now, once again, what is the level of significance? In order to measure this test of significance, or in order to apply this t-test and chi-square, we are going to use SPSS. There are very complicated mathematical formula which we need not study now, because we have got this easy software SPSS, with the help of which we can calculate the t-test and chi-square value. Once we apply this test, we are going to get some value. We should know how to interpret this value. The statistically derived value is greater than 0.05. Then the studied hypothesis is not significant, which means we are going to apply this t-test or chi-square, and we are going to get one value, the ultimate value. We get the level of significance by applying this software, where we have to check whether this value is less than 0.05 or more than 0.05. If the derived value is more than 0.05, then we have to reject the hypothesis. We have to say that there is no association between these two variables, which means higher income doesn't mean higher crime rate or lower crime rate. There is no significant relation between the income of the respondent and the rate of the crime. So the study which we have conducted does not lead to any conclusion. Now the second case, if the statistically derived value or the level of significance is less than 0.05 and greater than 0.01, there is only 5% chance for the occurrence of sample mean in comparison with the population mean. Then we can say the studied hypothesis moderately significant, which means there is 5% chance for the truthfulness of our hypothesis. If the statistically derived value falls between 0.05 and 0.01, we can say that there is some significance, there is some relationship between the income status of the respondent and the crime rate. We don't know still whether it is positive or negative. However, there is some moderate level of significance. There is at least 5% chance for such observation, for the truthfulness of such hypothesis. Now, in the last case, the statistically derived value or the level of significance is less than 0.01. The studied hypothesis is highly significant, which means there is only 1% chance for the occurrence of sample mean in comparison with this population mean. If we get the level of significance less than 0.01, we can say that our hypothesis is proved true. We can say 99% cases this is going to be true. There is very clearly proved relationship between the income status and the crime rate, either positive or negative. So these are the 3 levels of significance generally used in research. If the derived value is more than 0.05, then we have to reject the hypothesis. We can say that it is null hypothesis and there is no relationship between the 2 variables. We can't establish any relationship between the studied 2 variables. The value is between 0.05 and 0.01, which means there is some moderate significance. There is some relationship, some moderate significance. The relationship between 2 variables is moderately significant. The statistically derived value is less than 0.01. Sometimes you find 0.000, which means there is very high significance for the findings. We can accept the hypothesis. There is very high significant relationship between both the variables that are studied. Now, what is chi-square? Chi-square test provides us with a method to evaluate whether or not frequencies which have been empirically observed differ significantly from those which would be expected under certain set of theoretical assumptions. Now, chi-square test is a non-parametric test of significance. This is widely used test by social workers. Now here in this example, there is a table. This is called cross table or bivariate table. 2 variables are presented in this table. So what are these tables? What is the information in the table? Sexual abuse of street children by gender. So there are 2 variables. One, the gender, boys and girls. The other one, extent of sexual abuse, which is in 3 categories: high, medium and low. So we will find there boys, 38 boys who are sexually abused high, 20 boys medium, 12 boys low. In the same way, girls, 10 girls high, 26 medium and 6 low. So altogether observations are 112. So these are the observed count. So both these values are rather qualitative. We can say they are in the categorical or nominal and ordinal scale. Gender is nominal scale, boys and girls. Extent of sexual abuse is in the ordinal scale. There are no values in interval scale or ratio scale. Ratio scale is purely numerical variables. Here both of them are rather qualitative variables. So in this table we have to use only chi-square. There are other conditions for chi-square usage. No cell should have less than 5 observations. In this example we find all the cells have got more than 5 observations. Now we are going to use SPSS to calculate chi-square value. The SPSS, what we need to do, in this slide you will find SPSS. First of all, we have to decide the two variables. One is gender, the other one is extent of sexual abuse. After selecting these two variables, we have to create one cross tabulation. So, from the analysis, we can take tables, tabulation, where you have to take cross tab. The cross tab, you have to choose one variable in the row, the other one in the column. After choosing two variables, see the next slide, we have to click the statistics. The statistics button, there are two options, chi-square and correlation. I have told you earlier, for correlation also we can use SPSS. So both the place you can tick these check boxes. That means you have to select chi-square and correlation. Continue. After continue, in the main dialog box, OK. Then you will get the chi-square value in this way. If you closely observe the chi-square value, the last value, asymptomatic significance. The last one, two-tailed, two-sided significance. That is the level of significance. You will find all the levels of significance. There are three procedures used: Pearson's chi-square, likelihood ratio, linear by linear association. All these three values, you find the level of significance 000. What does it mean? There is a significant difference between girls and boys with regard to the gender abuse. So we can say that there is significant relation between gender and the sexual abuse of the street children. If there is a hypothesis that girls are abused more or boys are abused more, so in what way? Both the way, we can say that there is a significant association between the gender and the abuse. So in the given example, we will find out of the 42 girls, 26 girls are abused at medium level. Out of 70 boys, 20 boys are abused at medium level. Altogether 58 boys are abused either high or medium level. So we find the comparatively differences, some differences in the observation. And the test shows whether these observed differences are statistically significant. We can say that there is clearly significant difference between the two variables with regard to their association. Now, just to summarize how to use this SPSS to obtain this chi-square, from the menu, choose analyze, then take descriptive. Under descriptive, choose cross tab, then select the variables for row, select the variables for column. In the frequencies dialog box, click statistics, select chi-square, click OK in the main dialog box to run the procedure. If you follow this procedure in SPSS, you find the chi-square value. Now, how to use t-test? For estimating t-test in SPSS, we need to go to Analyze. Under the Analysis, The third option, compare means. The compare means there are option one sample t-test, independent samples t-test and paired sample t-test. So these three are the t-tests which we generally use. Paired sample t-test using SPSS. Select a pair of variables, click each of the two variables. The first variable appears in the current selection group as variable 1 and the second appears as variable 2. Paired sample test. After you have selected a pair of variables, click the arrow button to move the pair into the paired variable list. You may select more pairs of variables. Click OK in the main dialog box to run the procedure. Now independent sample test. Again you can from the menus choose analyze, choose compare means, choose independent sample t-test which I have shown you. Now when do we use these independent samples and paired samples? Paired sample t-test is used in the experimental design. So we collect the data from the same group before the experiment and after the experiment. The result we get from the data before the experiment is one data set. From the same respondent, after the experiment we collect some data, that is the second set. So two samples are collected from the same people, one result before the test, one result after the test, and we compare the result. And if there may be some observed difference, but using this t-test we can clearly statistically say whether this observed difference is statistically significant or not, whether it is sufficient to prove our hypothesis. Small differences may not be statistically significant. By conducting this t-test we can see the effectiveness of the experiment. We can clearly state that our experiment was successful or the hypothesis behind this experiment is successful if there is a significant differences between the mean before the test and after the test. In such situation we use paired sample t-test. When do we use this independent sample t-test? Now independent sample t-test, we have two samples, we have two sample means, but two from two different people, not from the same group. We can say one is the experimental group, the other one is control group. With the experimental group we have conducted the experiment, with the control group we did not have any experiment. From both the group we collect the data and we derive the mean from both the group. Both are independent samples because both do not belong to the same people. In such situation, we use this independent sample t-test. So whatever the procedure you use, ultimately you will get the value which is either above 0.05 or between 0.05 to 0.01 or below 0.01. Accordingly you have to interpret. If the value is more than 0.05, we can say that there is no statistical significance at all. If the value is between 0.05 and 0.01, we can say there is moderate significance. The value is less than 0.01, we can say that the relationship is highly significant. Hypothesis proved. Thank you.